Hi, this is our code walkthrough of projects 5 and 7. It combines an optical encoder and NEMA 17 stepper motor. The way it works is that using the optical encoder and the stepper motor, we use the ESP32 to measure and display the motor's RPM on an OLED screen. The motor speed is controlled in real time using a potentiometer, and the encoder tracks the motor's rotation through the 12 gaps in the rotating wheel. These are the libraries we use. The XLL library. It makes the motor run smoother than the stepper library. These are the OLED libraries. And then this is the stepper motor setup. These are the pins we use for the encoder, pin 3 and pin A0 for the pot. The end gap is the number of teeth we have in the reel. 12 teeth is 1 revolution. Here we just set up the OLED screen. And these are our variables. This will store the time. This previous state will store the encoder state, previous state. And then this will store the number of gaps. And this stores the RPM. In the setup, we begin the serial monitor. We set the encoder and pot pin as inputs. Here we initialize the stepper motor. The max speed would be at 800. The acceleration until it gets to the set speed, it will be at 100. And then the default speed will be 100 as well. Here we begin the OLED. If the OLED is not connected correctly, we will get a message on the serial monitor. We display a quick message on the OLED screen telling the user that the RPM motor is ready. We also read the initial encoder state. Here in the loop, the first line, we store the average RPM. We take 10 RPM readings and average them for a smoother display. We reset the gap count and begin time in milliseconds. We again read the encoder state. And then here, while the motor runs, we count the gaps. We read the pot value and use this to set the speed of the motor. Right here in the map speed, we have 0 and 10, 23. This is 0 volts. This would be 5 volts. Then the range of the motor speed from 100 to 800. This is a screenshot of that same code line, but this is the full equation. We then set the motor to run at this speed. We read the optical encoder and count each gap. We count the time it takes for one full revolution and convert these milliseconds per revolution to RPM. We accumulate the readings and then we compute the average RPM. Right here, we display the RPM on the OLED screen. And we had to clear the display each time because it stacks on top of another if you do not. Thank you.